Hi everyone, so today we are going to look at some general methodology and some research methodology terminology. So some of the things that we're going to be looking at today are different types of hypotheses, some variables. We're going to have a look at what lab experiments and field experiments are, something called experimental or participant designs, and also some general definitions that are relating to research methods. Okay, I'm going to start off with hypotheses. So a hypothesis is a prediction. It's a specific testable statement about the outcome of a test. Okay, so when you are planning an experiment, you will create a hypothesis to start with, which is your prediction about what is going to happen in the experiment. Now, there are two types of hypotheses generally, which are experimental hypothesis and null hypothesis. Your experimental hypothesis is the hypothesis or the prediction that you make about what's going to happen in the experiment, and it suggests a definite difference will be found in the data. The null hypothesis is almost like the opposite. So it's a prediction that is used in psychological research, which often states that no effect will be found other than one that might be by chance factors. So in psychology, we always have to consider that our results may not be necessarily due to the manipulation of the independent variable, and we have to always account for the fact that chance factors could have led to our results. So, examples of how to write experimental and a null hypothesis. So, I'm going to use this example of a study investigating the effect of glucose on memory. Now, in this experiment, our experimental hypothesis is what we are going to predict is going to be found. So it can be predicted that glucose will have a positive effect and improve memory. So that's our experimental prediction because that's what we think is going to happen. Our null hypothesis, on the other hand, is the opposite. Glucose will have no significant effect on memory. So we're obviously accounting for the fact that chance factors could have affected the result, and the manipulation of our independent variable did not affect the result. Here's an example which you could have a go at writing. So a study that wants to investigate the effect of alcohol on driving performance. So at this point, you can pause the video and see if you can write down an experimental and a null hypothesis. You've also got one-tailed and two-tailed hypothesis. So a directional or a one-tailed hypothesis will predict a specific difference is going to be found between the conditions. So this is when you've got so much research that you can make a clear prediction about what is going to happen in your experiment. A non-directional or a two-tailed predicts that there will be a difference between the conditions, but that difference will not always be stated. For example, if you are predicting that there's going to be a difference between boys and girls' memory, that would be a two-tailed hypothesis because we know there's going to be a difference between the genders' memory, but we don't know whose is going to be better. So that would be two-tailed. A one-tailed of the same experiment would be that males have or boys have a better memory than girls than females. Okay, so just to help you remember, you can use the example of a fish. So you can see the top fish is a one-tailed fish, and that predicts a clear direction. In other words, the fish can swim in a specific direction. Whereas your second diagram is a fish with two tails, which is obviously just made up. But what this shows is that there is no direction for that fish to go. So again, there, that you could use that to help you, understand the difference between a one-tailed and a two-tailed. So remember, one-tailed is a specific difference, and a two-tailed says there's going to be a difference, but we don't know what that difference is going to be. Example, a study investigating the effect of gender on obedience to authority. So in a two-tailed hypothesis, we will state there will be a significant difference in obedience between males and females. Note that word difference is in there, which kind of gives us a bit of a hint that it could be two-tailed. And a one-tailed would be a clear direction. So females would be more obedient to authority than males. So with a one-tailed, we're predicting, is it going to be more, is it going to be less? We're predicting the specific direction in which the results will go. Whereas with the two-tailed, again, we're saying that there's going to be a difference, but we don't know what that difference is going to be. Here's some examples which you could have a go at. So you may want to pause the video at this point and have a go at working out whether these are one-tailed or two-tailed. Next, we're going to have a look at different types of variables in an experiment. So the two main experimental variables are an independent variable, or an IV, and a dependent variable, or a DV. So an independent variable is the one that you normally manipulate or change in an experiment. And the dependent variable is normally the one that you measure. So, example, in a study on gender and mathematical ability, the independent variable would be gender, because we're looking at the difference between genders, and the dependent variable is what we're going to be measuring, would be the mathematical ability. The easy way to remember this is I've changed, so that's the one that you normally change, okay? And obviously dependent is the other one that you measure. There are some other variables which you also need to know about. Because we can't, as researchers, it's very difficult to control every single variable in an experiment and make it as valid or reliable as possible. And there's something called extraneous variables, which are variables apart from the independent variable, which could also impact your dependent variable. And these can be situational or participant variables. So firstly, situational variables are mostly relating to the environment in which your experiment is carried out. So things like weather, noise, temperature of a room, these are variables that we don't really have control of, and especially if it's being conducted outdoors in a field experiment, we have very little control. And secondly, we've got participant variables, and these are relating to characteristics of the participant themselves. So the tiredness, fatigue, IQ levels, memory, tolerance, etc. So participant variables are actually relating to individual differences which occur between the participants. We've also got confounding variables, and confounding variables are a special type of extraneous variable where the extraneous variable changes systematically with the independent variable. So what this means is that you cannot really be sure that the changes in your experiment are necessarily due to the independent variable. For example, if we were looking at a study on whether people remember familiar words or unfamiliar words, the familiar words would be presented first in the list. This is an example. If we found in that experiment that familiar words were actually better remembered than unfamiliar words, we can't, however, be sure that they were recalled better because the familiar words were presented first. So therefore, it might be that because they were presented first, that they were better remembered. So what confounding variables are is to do with the way you conduct your experiment, which could also impact your results, affecting its validity. Here's just an example of another study which you could get some practice identifying the independent variable, dependent, and any extraneous variables. So you could pause the video and have a go in identifying these. Next is laboratory experiments. Lab experiments are conducted in a very tightly controlled setting where the independent variable is directly manipulated by the researcher to see how it affects the dependent variable. Lab experiments do investigate cause and effect whilst trying to test a given prediction. So participants are usually aware that they are taking part in an experiment if it's a lab experiment, although they may not know the true aims of the study. So lab experiments do sort of give us establish a cause and effect relationship, and what that means is we have a lot of control in a lab. Therefore, we can make sure that it is definitely IV that is causing the DV to change. So that's what cause and effect relationship is. Okay, the IV and the DV. Evaluation of lab experiments. So lab experiments are very good in the most popular method used in psychology. They do let us have good control over variables, which makes them a lot more applicable and reliable. Cause and effect, as I was talking before, relationship can be established in a controlled setting, which again adds to the reliability of the lab experiment. However, there are some problems because it is, at the end of the day, an artificial environment or setting which does lack something called ecological validity. So what that means is the participants' behaviour may not necessarily be valid or natural in an artificial setting. We've also got something called demand characteristics, which is quite likely in a lab experiment because lab experiments are likely to affect the validity of the experiment. In other words, participants are likely to guess the aim of the research if it is a lab experiment. Field experiments are very similar to lab experiments in the way they're conducted, and the researcher still manipulates the IV to see how it affects the dependent variable. But the difference between a lab and a field is a field experiment does take place in a natural setting for the participant. So it might be in a school, it might be in a shopping centre, it might be in a park, it will be in a home, a nursery. It's a natural setting for participants. The researcher does still have control over some of the variables, but a very little control of the environment, especially if it's conducted in an outdoor setting. Evaluation of field experiments. So because it's a natural setting, it does make field experiments a lot more valid than lab experiments because the participants' behaviour will also be natural. However, participants are not always aware that they're being studied, therefore avoiding demand characteristics, which does increase its validity. Researchers have less control in a field experiment. So in other words, it's very difficult to control all factors because it's not in a controlled setting, and that can reduce the validity of the experiment. It is more time consuming, however, to conduct compared to a lab experiment. And there are likely to be ethical issues, and especially if participants are not aware they are taking part. So next we're going to be moving on to participant designs or experimental designs. And participant designs, there are three main types. And this is really how researchers actually use the participants. We've got independent measures, repeated measures, and match pairs design. And independent measures then. So in an independent measures design, two or more groups of participants are used in the experiment, and they consist of different individuals. So participants basically take part in only one condition of the experiment. For example, if you're comparing 20 boys or 20 girls on reading tests, you'd have 20 boys in one group and 20 girls in another. So they only take part once, basically. This type of design does avoid order effects. So remember, order effects and demand characteristics are effects that could potentially affect the validity of an experiment. So order effects could be fatigue, practice effects, and demand characteristics is where participants could guess the aim of the research. So it does avoid those as a strength. Lack of control over participant variables, because we're using 40 participants, for example, in this study. We could potentially have a lot of participant variables, so a range of IQ levels, a range of ages, and it is very difficult to control all variables in an independent measures design. Also, a problem is that we do need a lot of participants in independent measure design, and sometimes it can be very difficult to obtain the amount that we want to. The second type of design is a repeated measures design. This is where participants are tested on 2 or more separate occasions. So the same participant is used basically in each condition. For example, if you test 10 participants on 2 different IQ tests and then compare the results, or if you test concentration levels in the morning compared to the afternoon, you use the same participants. This type of design does enable the researcher to have good control over participant variables, as obviously the same participant is tested. However, order effects and demand characteristics are more likely with this type of design because participants are taking part twice, so they may get bored, they may get tired, they may show practice effects as well, or even guessing the aim of the research. A good thing is that fewer participants are needed than an independent measures design. With a match pairs design then, different participants are matched on important variables such as age, background, etc. So we're basically in a match pairs making sure all our participants have something in common. So it could be similar age, and same amount of genders, intelligence score, personality test scores. So we're making sure that they have similar traits. And the reason for doing this is for eliminating the fact that individual participant variables could affect the validity of an experiment. This match pairs enables good control over variables. It does avoid order effects, as it's a little bit like an independent measures design. However, it is very time consuming to match participants on all variables, and it can be difficult to find as many participants to make sure that they are exactly the same age, the same level of intelligence, same personality test scores, etc. So it can be difficult to find enough participants. We're just going to finish off with some definitions which are really important for you to understand in psychology. So firstly, we've got order effects, and I've talked about order effects already quite a bit. Just wanted to give you some definitions. So order effects occur mostly in repeated measures design, including things like practice effects and fatigue effects. So these could potentially affect the validity of a study. So with a practice effect, the participant takes part in more than once. And this can lead to a participant actually achieving a better score because they've taken part in it twice. And also tiredness, fatigue as well, which could impact the results. Counterbalancing, this is a method of actually controlling order effects by having some participants do one task first and then the rest of the participants doing the other task first. So what you're doing is in effect changing the order in which participants complete the tasks. So this will cancel out any practice effects, basically making it more valid. Operationalization. This is basically just a term which we use to make sure that variables are defined in a way that we can easily measure them and test them. For example, if you were doing a memory test, you would operationalize the variables by making sure that your test, your test of memory, for example, if you're testing them on a list of words, is a count of the number of words recalled. So you're operationalizing it by making sure it's measurable and testable. And the final definition is experimenter effects. And these are really ways in which the experimenter can accidentally influence the participants through their behavior. And sometimes researchers might do this by the tone of their voice, the way they talk, which can lead to them being a little bit biased in collection of data. Okay, so there you have it, just a summary of some of the main terms really in research methodology within psychology.